things worked in that rhizosphere. You have all these organisms in there, must be doing something. Mother Nature doesn't just leave things doing their stuff without there being a darn good reason for them to be doing that. We just had to figure out what they were really doing. And so, doing a number of different experiments, looking through the microscope. And so that was a very important part of what I was doing, was to discover a very simple and easy way to determine whether you had too many fungal hyphae, whether it was just about the right amount, or it was too low with the fungal hyphae. And another thing that we found was quite recently was when you look at bacteria, their biomass has to contain 5 carbons, 1 nitrogen. When you look at the foods that bacteria eat, generally, they have 30 carbons, 1 nitrogen. So when a bacterium eats anything that it likes to eat, that means it's being stressed for the lack of nitrogen. So what do you do as a bacterium? How do you get rid of all those excess carbons? You blow them off as CO2. Every time you till your ground, and bacteria can tolerate being,
Phil.
uh, tilled. Yeah. So
Phil,
they,
Phil.
yeah, yeah. But the fungi, they're all sliced and diced and crushed, and, it's really bad news. So all of that extra carbon, all those extra food resources that the fungi used to be able to control, they're going to be chewed on by the bacteria, which is even more of your organic matter getting blown off into the air, because bacteria are inefficient on carbon. Carbon is not what controls what bacteria do. So what do we have to do to bring back that ability to sequester all that carbon in the soil? We have to grow fungi. So fungi have a carbon and nitrogen ratio of, maybe something like 60 to 100 carbons for every 1 nitrogen. And so when a fungus is eating any kind of food that it's got, it's in that range as well. And so the fungi are going to take all that extra carbon and put it down on the inside of the hypha, storing that carbon there. And so we increase the amount of carbon that can be put away, not blown off as CO2. It stays in the biomass of the fungus. But every time we slice and dice and crush those fungi, think of all the massive amounts of carbon that are going to be converted into CO2 by the bacteria. So because we don't understand these things yet, we allow people to get away with these kinds of behavior. I hope we convince them not to be so foolish in their uses of their natural resources.